Okay, so with that interesting last presentation, it's up to me to close the conference now. But before I do so, I'd just like to offer some suggestions for future directions for robust design research, in particular what we're interested in at the moment at DTU. And it's basically a call for collaboration or collaborative research. So just to give you a quick bit of a introduction to the way our robust design program is set up at DTU. Well, our main collaborator at the moment is Novo Nordisk. And the way we've aligned or created a framework for our research program is based around a simple model. And we can ask, how much force does it take to push this pen lid onto this pen? And to describe that, we can set up a basic transfer function where we have the design parameter of the pen lid here and a nominal value, and the function requirement of the press-on force, and of course there's some kind of transfer function between the two and the variation. So one of our PhD projects is working in this area, in the robust design area of reducing sensitivity, looking at axiomatic design, but also multiple function requirements and design parameters. This is a very simple model where we've just got one DP and one FR. But of course, that's not a realistic situation. Now, we can spend a lot of money and time trying to optimize around this nominal value, but what happens if that nominal value isn't the right nominal value? What happens if people don't want a 10 Newton press-on force, they want a 12 Newton press-on force? So we're connecting the transfer function to some kind of quality loss function and trying to evaluate where the actual functional requirement specification should be set based on quality loss. And to do that, we're also looking at sensory robustness. So one of them is visual robustness. Here's a very nice case study on vacuum cleaners. And these two products here have actually the same ingoing variation, meaning the panels are misaligned as much in this one as they are in this one. But because of visual robustness, we can see this looks dreadful quality. In other words, this would be a very steep line here, whereas in this one, it's very visually robust. We can't actually see the variation, so it would have a very flat quality loss profile. And that's where our other PhD project from CERN is looking at in this area. The third PhD project is in the production end, looking at how process variables relate to the design parameters. And then the fourth work package is understanding that all around this circle there is variation. And at some point we have to make a decision, okay, we're here, we're experiencing some kind of quality loss in the market, and it is costing us. How much is it costing us, and what should we do to solve that? Should we invest in another design loop to try and reduce the sensitivity, this gradient? Should we invest in tighten up our variation output, or should we invest in process control and variation control during our processes? So there's various ways we can play our tokens, or we can perhaps even just accept a bit of quality loss in the market. But somewhere we have to have a framework to decide how to make these decisions. A little advertisement, we have 2 vacancies if you would like to join the group. One as a senior researcher position to help drive this research framework, and another as a PhD researcher. So if any of your colleagues or anyone's interested, please let me know. And then just a little bit about one of the future research activities we'd like to engage in. You may have heard of the Horizon 2020 program, and we're hoping to put a bid into this soon based on a global process capability database. Now, this is very simplistic, but we'd say that the normal way of setting a tolerance is a designer decides on a concept, they set the geometry to meet a specification, they set the tolerance limits to hold within the specification, then they pass this on to production, and then they see whether production is able to make it. Maybe production send it back to them, or they try it and realize it's out of their process capabilities, in which case the designer has to then redesign. Where we'd like to move towards is design to process capabilities. So the designer should have a very good understanding of what the process capabilities of the production unit is from the beginning. So they can decide on a concept, they can set the geometry, and then check whether the features in their design are within process capabilities. Then obviously if they're not, they do a redesign before sending to production for approval. So this is where we want to get to. But how do we do this? Well, we need good data from production, and we need an easy way for designers to interpret it. So it needs to be user-friendly for a designer. They don't need to have to do a production degree before they can evaluate it. Now, current approaches include tolerance standards and guidebooks, but the problem with these is the standards actually conflict. They have various different outputs. It's also often based on very old data, which is static data. And usually we only can get general guidelines for linear dimensions and holes and shafts. The other approach is for a designer to go and ask a process capability expert. And of course the problems with that is you get subjective judgment. It relies on the expert being available at the time, maybe they're not. And it relies on whether the expert can recall a suitable similar case from the past to base their judgment on. So our proposal is we'd like to come up with a way of creating a process capability database based on quite a standard approach where we go through the design and development phase, we produce our visual representation, we then manufacture the parts, do some measurement reports which feeds into a process capability database, and of course there's the assembly process. And then how we actually use the data is coming up with some design guide or user interface or CAD plugin so that the designers can interpret the variation data during the development process. And that would be relating it to the GD&T tolerances. But where we really want to take this forward in research terms is to incorporate big data into manufacturing. So what we'd actually like to do is do this process in collaboration with DTI, who will do the measurement reports for us, put into a process capability database which can then be used by the designers or to optimize production and assembly. But it could also be used to validate the components provided by external suppliers. And we'd like to do this for a number of companies. And then the big challenge is to take this process capability data from all of these company process capability databases, anonymize them, and put it into a global database. Then we can have a designer interface here. Now, why would we want to do that? What's the advantages? Well, some of the motivations would include to create a new superior Danish or European tolerance standard based on big data that is current, which is constantly updating based on current process capabilities. Then we can allow process capability benchmarking. So if we have the anonymized data of the current gold standard for injection molding, you can basically put your company's process capabilities into this system and work out where you are in terms of, are you a market leader or have you got huge room for improvement? We can enable certification, so we could actually take parts and verify them from the whole supply chain to work out whether your supply chain is actually producing to the grades they suggest they are. Then also produce this interface to allow for design to process capability. And the most important thing, rather than being a static, out-of-date thing, it would keep growing and living as every time a part is validated. So in terms of our partners, we have principal agreements from Novo Nordisk and Grundfos. In Novo Nordisk case, we have the PhD signed off already. In Grundfos, we have a rough verbal agreement, and we hope that the PhD project will be signed off by the end of this year. We also have expressions of interest from Radiometer, and hopefully we can convince Lego at some point to join the party. And these are basically the idea of we want to build process capability databases within their companies which are usable by designers, and then in a safe and secure manner anonymize the data which can then be globally abstracted. So if you are interested in this project and you want to join us on a Horizon 2020 bid, please let us know. But now coming to the closing of the ceremony. Thank you very much for your data inputs with regards to your use of methods and tools. Our student helpers or participants actually did a good job in digitalizing your data. And some of the things we found in terms of the broad level conclusions was there was a large spread of methods used. Most of them used were tolerance design, DOE, and kinematic design. There was low knowledge and usage of VMEA and functional failure design, so there seems to be a bit of a blank spot in our knowledge as a community within these tools. Excel is by far and away the most used software. And VMEA and axiomatic design, although axiomatic design seems to be well known, has no software to support it at the moment. Now, thank you very much for your contributions, your papers and your reviews and so on. Everything is now available on the website by the downloads link. Extremely well put together page by our organizing committee, but you can download the full proceedings or the individual papers. They are completely open access. Also, all the video files, the presentations, the posters will be available on there soon. And also, you can download all of the workshop material from yesterday from the forensic engineering workshop. So it should be quite a useful resource. I'd also like to, and we can applaud after a next slide, but say thank you to the reviewers who reviewed very well and timely, and also the authors for their really good responses to the reviewers' comments. I'll move on and also thank the organizing committee, which comprised of myself as the chair, Tobias Eifler, as the co-chair, Søren Pellison, Martin Ebro, Moritz Kohler, Andreas, Ariane, and Jonas, who actually worked a lot on the forensic engineering case yesterday. So I think if we can just give them, everyone, a round of applause for all their efforts. So thank you. And I think although everybody contributed extremely well, and equally some contributed more equally than others, and in particular I'd like to pay a big thank you to the two guys, so if you'd like to stand up, guys. Andreas and Ariane, who basically put together the entire proceedings, did the website. Everything that looks super professional about this conference is down to these two guys, really. So please do me a favor and do not employ them. Leave them working with us for a while. But thank you, guys. So where now? I think this was a good event and it was very well supported by Danish industry. So what do we do from here on? Well, I think we won't make it a two-day event in the future, perhaps a yearly one-day event where we'll invite some speakers along and hopefully see you each year, and it will be perhaps hosted at DTU, but of course we're open like they are for groups to having other locations for the event. And I think we'll call it the Robust Design Day. So we look forward to your future participation. But what about ISORD 16? So the idea is this conference is put on by the Robust Design Special Interest Group. And where is the second one going to be held? Well, one motivation is this is now relatively obsolete, and there is a new version of the Vavwood Wind Reader, which now measures wind direction. So Andreas, if you can perhaps do the same again in 2 years' time. But I'd just like to introduce the hosts of ISORD 16, which are Erlang and Nuremberg. This is the chair of Professor Warschak, and luckily we have a representative from Nuremberg, Benjamin Schleck, who's just going to present a few slides.
So just give a brief introduction or a brief of the Chair of Engineering Design in Erlangen. We are proud to host the ISORD in 2016. And basically the motivation of our chair is from the creative idea to the systematically optimized product. So our research deals with a lot of things, from bearings and mountings to the topological coding systems, but also of course dimensional management. So we had 2 presentations and a poster this year. Also lightweight design, and we're also focused on teaching and education of tolerance analysis, geometrical variations management, and of course also robust design. So especially in tolerancing, we have two main issues right now. This one is tolerance cost optimization of systems in motion, and the other one was what I presented yesterday, basically the tolerance analysis based on discrete geometry representations. But of course, we are very proud to also work with many industry firms and companies also internationally. We're quite well connected with French colleagues and also, of course, in the design society. So we're very proud to welcome you to the International Symposium on Robust Design 2016, and it is on. And we thank, of course, the organizing committee for this very, very nice event.
And if you haven't had enough last night, there should be some beers and coffee and some drinks outside now. So go and enjoy yourself for the rest of the day.